So hello everyone. Thank you for joining us today for this workshop. A statistical workshop number 2, because we did one statistical workshop, that statistical analysis, but using Minitab. And today we'll talk about how to do your statistical testing in Excel from basic to advanced. So like most of us, we don't know how to use Excel, or we use Excel only for the basic statistical. But Excel also have advanced statistical testing. You can do it in different program, but also you can do it in the Excel sheet. So thank you once again for joining us today. And so this workshop is designed for those who are facing challenges in statistical analysis, offering practical approach to mastering essential statistical tests using Excel. That means whenever you are a beginner or looking for just to refine your skills, so this session will provide valuable insights to enhance your data analysis expertise. So today we are honored to have Mr. Zinabu, Hailu, a lecturer at Adigrat University, Ethiopia, and a Ph.D. student, a Ph.D. candidate at the Hungarian University of Agricultural and Life Sciences in Hungary. So as our esteemed speaker, so the expertise in statistical analysis will provide you with a valuable knowledge and practical techniques just to strengthen your research skills. We sincerely just appreciate his time and effort in sharing his expertise with us. So a special thanks or just thank you to all of you for joining us today. And also we encourage you to actively participate in the discussion, ask questions, make the most of this learning opportunity, just because your engagement will reach the sessions and benefit every one of us. So let us make this an interactive and insight workshop. And also if you have any idea or something to use the Excel sheet for different analysis, also just you can share this expertise with us by the end of this lectures. And also if you have a question, also just try to write your question in the chat, or just wait until the end of the session, and then we'll give you the chance to ask your question directly by opening your mic. So the floor is yours, Mr. Zinabu.
Okay. Thank you, Emad, for your introduction. So I will continue the second workshop, which is focused on the hands-on statistical testing analysis on Excel from the basic to the advanced level. So with this, we will see the basic distributive statistics in Excel, and then the inferential statistics, especially with testing hypotheses like t-testing, ANOVA, regression, correlation, something. And then next we will see the more advanced the mathematical modeling. At the end, we will see also the design experts, especially the factorial parts. To give the highlight, we will see more on the practical base, but to recap, to summarize, on the descriptive part, I think we will see the accuracy and the precision measurement technique, like the central tendency, mean, median, and more. As precision, we'll see the variance standard deviation of our data, how we can analyze in Excel. So we can proceed with two approaches. The first one, we can use the Excel function base, like average function, median function, mode, standard deviation, variance. These are the functions that exist with the Excel. So we can use this directly, and we can get the result from that Excel. Or the second approach, we can use the add-in data analysis tool. So with that part, we can select the descriptive statistics, and we'll get the summary of the output. So we'll see the different parameters like in agricultural research. Let's say if we would like to investigate the food quality attributes, firmness, soluble solid, weight loss, color, pH, something like that, we'll use the summary, the average of our experimental treatment. With this one, the first one, and the second is the basic inferential statistics, which is hypothesis testing. If we are going to compare two sample groups, the mean of the two sample groups, we can use two sample t-test, or if we have only one measurement parameter, we can use one sample t-test. So to compare with the true mean or to compare with the average value, this can approach at the same time from the Excel function t.test, or we can use also the data analysis add-in, then we'll get the result. The third part is the ANOVA. An ANOVA will compare more than two groups, like 3 and more, with, if we consider one factor, so we'll use one-way ANOVA technique. If we'll consider two factor, we'll use the two-way ANOVA factor. So this also can be done with the data analysis tool and the add-in of the Excel. Practically, we'll see later on. So at the end, we'll get the summary of the ANOVA result with the p-value, with the f-value, and with the different degree of freedom, number of observations. Every these are summarized in the results. So if we're gonna to proceed with the post hoc test, also we can calculate manually the post hoc test in Excel by this mathematical formula, and the Q can get this Q value from the Q table, as is seen in the right hand side, this table. You can use the degree of freedom to the row side, and you can see the number of the group you are going to compare. So this, the center value is the Q. So this mean square error can get from the ANOVA summary, and this also. So you'll calculate for the post hoc test value, and then you can compare between groups how it looks like. Either have significant difference or not between the groups. And the fourth part, the correlation analysis, here to look or to make analyze how the linear relationship between variables, how it looks like this. Let's say if we are going to see the quality of the food after harvest, the quality parameter is, let's say, soluble solid, and the other is pH, firmness, something. So if we wanna to look how the correlation between these variables, we can use the Pearson's correlation coefficient value. So this can approach by two ways. One, using directly the core function from the Excel itself, or the second one with the data analysis and get this correlation. And the fifth part is the regression part. We can simply with this data analysis tool, we can use the simple linear regression to estimate the dependent variable by the independent variable, like y is equal to mx plus b, this the slope plus intercept. So this also approach by the tool data analysis, as well as with the function line set. So in the second part, we'll see the mathematical modeling. This is very advanced level. let's say if we have a measurement with reaction rate, let's say this is the theoretical model which developed by Arhens. This is Arhens equation, which used to characterize the temperature dependence reaction rate. As we know, the fruits and vegetables, let's say after harvest, they gonna respire. So during respiration, there is a breakdown of glucose into carbon dioxide plus water. So this carbon dioxide can measure as respiration rate at this, as you see in this mathematical equation. Respiration rate can be measured by the carbon dioxide produced or oxygen consumed over the mass of the fruit times time. So with this, we can measure, we can model our measurement. Let's say this is the trial, the tomato, let's say the cultivar tomato, after we harvest, if we store at different temperature, like 1 degree centigrade, 5, 10, 50, 20, like that, and we measure the respiration rates at some time interval, like this is the 4-day, this 8-day and 12-day and 60-day. We have this respiration data from our measurement. So now we are going to model with Arhens equation. So first we have to do, this temperature can be converted to the Kelvin, and then we transfer into linear approach. So this linear can be done by plotting 1 over temperature versus ln of respiration. This can be calculated with this. K is equal to K is reaction constant, A times the exponential activation energy divided by the RT. This will prove here that like this, I think I will call if the pen is working. The Arhens equation is like this. K is equal to A times exponential minus activation energy over a gas constant times temperature. So if we divide this, and then if we multiply both by ln or logarithm, so ln K minus ln A is equal to this activation energy minus of activation energy over RT. This, it will left. So ln K is equal to this activation energy over RT plus ln A. So this is the slope. This is the slope, and this is the intercept. So we can plot ln K versus T, and then we'll get the model of the Arhens equation. So at the end, we can report the summary of these parameters. These are the very important parameters, the reaction constant, how it's like with temperature and with time, how the reaction rate goes. The activation energy, the energy, I think at that time, it's an exothermic reaction, it would happen. So how much energy is released or produced from the respiration rates. And these are how the model fits the correlation R square can be determined. We can summarize with this table. The other one, we can also use another add-in tool, which is called solver. This is very important to optimize the variables to minimize the standard error of this predicted and the measured value. Let's say if we have a measurement with time versus temperature with different rate, and then we are going to make a curve fitting with this theoretical formula. So first, initially we put this variable. These variables are a variable which needs to optimize in order to reduce between the measured value and the predicted value. So with this one, we have to follow the following steps. First, we will gonna to calculate the predicted temperature using this theoretical formula, and then we will compute the measured one, subtract by the predicted value square to get the sum square error, and then we will sum all these to get the sum square error. And then after that, we'll go to the solver from the Excel. Later, in practical, we'll see how it goes. And then finally, we'll compute the R square with correlation measured value, comma, with the predicted value square. The final one, we can also use an Excel design of experiment. We can design. Let's say this is a model example for factorial design with 3 factors, to the power of 3. We have 3 factors with 2 levels. Let's say this is a popcorn yield value. This yield value is depend on the temperature, time, and energy, and their interaction effect. So now we are going to optimize the best process, how it looks like. So to do this, we'll design this design of experiment. Finally, we'll see by data analysis tool using a regression model, we can predict which are the major coefficient of parameter that needs to control or needs to optimize. So this is the last part from design of experiment. This is already the highlight of the theoretical aspect. Now we're gonna to the Excel part, the practical one. If you have any question, I can. Otherwise, I can proceed with the practical one.
Hello, thank you so much for giving the very detailed information about the statistical testing in Excel. So like this, if anyone have a questions, just you can raise your hand. We will give you a chance to ask your questions, or you can ask your question at the end of the session. Does anyone have a questions before we proceed to the second part? Okay, if there's no one, proceed with the second part. Yeah, maybe by the end of the session.
Okay, that's good.
The chance for discussion.
Okay, I will start from the basic one. Let's say this is data like a firmness data. Okay, this is the firmness data, firmness of one fruit. Let's say after post-harvest, and then this fruit is stored at a temperature of 1, 5, 10, and 15 for 20 days. So the firmness measurement was taken every 4 days. So these are the data sheet. So now, first you have to make sure in your Excel you have to go to the option, and then you have to check the add in, and then from add in you have to check this analysis to packs analysis, this and this, the two, this solver and this one. And after that you have to go to the go, and then we have to make sure whether they are ticked or unticked. If they are not unticked, you have to make the tick, this tool analysis, tool back and solver. Then after we make this, we can go to the data, and we'll get here the data analysis and the solver. So from the data analysis, I will get into the descriptive statics here, look, and then I will choose this one. So input the range, that makes the descriptive statics. So I will put this all parameter here. I will in the level, and we can take this one to get the output. So give me the output here. I select this point. Okay. Yes. Column, yes. Summary, no. Summary statics, we have to take this one. Now we can get like the summary. Oh, no. Look, this one is the mean for F1, the mean, this is the standard error, this is the median, and this is the mode, standard deviation, skewness, cortesis, range, minimum, maximum. So we have this for every treatment group. For example, which stored as 1D single, 5, 10, and 15. So we can use this for basic distributive statistics, or we can also use the function here. Let's say I can make average here to get the mean from this to this, and then if we make enter, so I get 17.66. If we wanna to calculate standard deviation of the sample, we can select this, the sample standard deviation. So again, I will calculate this. Here, look, we get this mean standard deviation, and we can also add the average, okay, of the second one. And equal to standard deviation of the sample, the second one. And the third, okay, and rank. Here, this is the third one, and this is the fourth one. Oh, this is the fourth, So I have this temperature. We can compare the result this, how they are be similar with this. You can compare with this one. No, this is okay. Yeah, here this is calculated, and look, the mean both are similar, yeah. And you can check this and this. Now, if you want to make, okay, 1, 5, 10, and 15. If you wanna make a visualization, we can make this is categorical. So I will choose this plot, and you can make this and go to the insert and then chart. I'll select this one. Look. So now I would like to add here standard deviation, the error bar. If you want to add error bar, you can go to the plus sign and go to the error bar. Here you have an error bar, and then select the more option, and then from this I will use the custom one, because I have when I use the standard deviation which I get from the calculation from the existing data. So I will specify. So I will put this standard deviation value here, and then we'll get, this is the standard deviation with error bar, mean plus standard deviation. So now this level should be corrected. So first you have to click this and then select the data here, and you can edit this one. Is equal to this bracket, then 1, 5, 10, 15. I put there. Okay. And then you have to make the axis clear. So this is the terminus, and this is temperature. Okay, I have to make the border line, so I will select this, the axis line, I mean. I'll select this axis, and I will choose solid line here, and I will name this with a width of like 1 point. And I will use the tick mark for outside for major, and I will increase the font to like 80 less, and this also. Similarly, I will put for this, select this one, go to the format, and I will use solid line here, and then make sure I will increase the width. Oh, okay. That one. If this is not necessary, okay. Tick mark if it's okay. Sorry, but it's not good for this. I don't know why. Okay. We can customize this one. Look, okay. And we can delete this this one by clicking. And then if we wanted to fill another color, this filling, we can choose lesson, no border, okay, fill, so fill. So we can present like this. From this, if we get, let's say, post hoc test value for this, let's say A, B, C, D, and then we can also label this in the error bar, like you can click on plus and then go to the data level. If you go to the data level, and then you can choose the more option, and then here you click this one, label option, you will get it. After that, select from the cell, and then I will input these values. Okay, then I will remove these values and show leader lines. So here we can drag to the upside. We can drag to this. And so you can increase this, the size. As bold. Okay. Bold. So like this, you can present or report your result like this. This is the basic statistics. So do you have question here on the basic statistics and making visualization? If not, I will proceed to the ANOVA.
And then we'll give chance by the end of the session.
Can I proceed?
Yeah.
Okay, cool. So similarly for ANOVA, we can ANOVA, the objective of ANOVA is to compare the means for more than 3 groups. So we can go, we have here 4 group. So our factor is here, let's say temperature one way. If we consider the temperature, one way it will be. If we only focus the time, here we have is one way. If we consider both of them, it will be two-way ANOVA. So now I will show you the one way of ANOVA. Similarly, we can go to the data and data analysis. Then ANOVA with single factor. Click, and then we can similarly select and the output for this, as we can put here. Yeah, look. So this is the summary of one-way ANOVA. Let's say we have the F1, F2, F3, F4. These are the 4 groups. And we have this total sample number. F1, we have 103. N, this is N. In other words, number of observation. And this is the mean we have. And this is we have the variance. From this, we can also compute the standard deviation. Standard deviation is square root of this value. This. Here. And we can also compute the standard error. Standard error is equal to the standard deviation divided by square root of n, this. Now, the post hoc test with the Turkey post hoc test, we can also compute the Turkey. Post hoc. Oh no. Yes, yes. Test. First, we have to determine degree of freedom, this, and number of group. Here, number of group we have is the 4, and degree of freedom is 3. So we can read the Q from the table that previously we have seen from the PPT here. So number of the group is here. We have 4, and degree of freedom is 3. So we can go from 3 to the horizontal direction and from the 4 to the down direction. So the point is here, 6.825 is the Q value. So Q, the postal test can be calculated by the Q times the mean square error from the ANOVA divided by N. This is the calculation. So the mean square error is here, divided by the square root of, and divide by the number of observation. Let's say we will focus the smallest one, this N here, and times the Q from the table, 6.825. So this is the HSV value And then here we have to make the pair, the comparison pair. That mean one, F1 and F2, we have to compare F1 to F2, F1 to F3, F1 to F4, and F2 to F3, F2 to F4, and F3 to F4. 1, 2, 3, 4, 5, 6. Yeah, this is the pair for group. You know, the formula like the pair are this. So now we have to subtract this, the mean value, the pair mean value, the absolute value of absolute equal to absolute value of this minus this, and absolute value of this minus the third one is this, and the absolute value of this minus the fourth. Okay, well, and second, the absolute value of this minus this, and the absolute value of and this minus this, the absolute value of this minus the fourth. Now these are value. So if this value, the H value is less than this pair value, they have significant difference. We say they are significantly different, the two groups. Now 6, this, okay, I will put here this one, copy, and then paste, and copy, and then I rotate this one, so I put okay, sorry. Okay. Now this is greater than this, yeah, so significant, they are significantly different. This is different from this also significant, these groups, you know. Okay. So this also significant, here not significant. This is not significant. And not significant. Not significant. So you can label the postdoctors like A, B, like this for the significant. This is A, like B, and then this is significance again C. Okay, B, C, then B, C. Yes. Okay. This A. Okay. F1 is significant with 2. F1 with 3 significant with 4 significant. This is okay. A. You can say 1 since the 1 is the very important. And these are BB. Not significant. You can put like BB. No. Oh, this is the post hoc test. Manually, how can you calculate? But you can use also, I think there are an add-in tools. Another, if you give the tools, you can simply use automatic. For manual or mathematically, you can compete in this way. So it's clear, Anovan. So the very important parameter are here, the F value and P value. So these are between, it says there is a significant difference between groups. They don't the firmness, the firmness of the food which is stored at a temperature of 1, 5, 10, and 15. They have significantly different firmness value. This is what you have to report in the document, and they can also visualize with the post hoc test mean with the standard error. Okay, it's clear, Anovan? Similar for two-way, you can use two-factor, you can include the factor. So this tool is very important tool. You have two-factor with replication, Anovan. You can use, if you have two-factor, three-factor, you can do these things. But the concept or the way is similar. Next, we'll see the data. Okay. Mm-hmm. Respiration. Okay, respiration with the okay, we'll use this data, okay. Mm. Mm-hmm. So now first I will set the temperature. This value I will take here. Okay. The 4. Okay. The equation was okay. is equal to A exponent activation energy over RT. So now first we have to convert this temperature into Kelvin. So Kelvin is equal to temperature plus 273, yeah? So this temperature plus 273. I mean 1 is equal to 273 plus 1. 273 plus 5. 273 plus 10. 473 plus 15. And then I will convert to this 1 over T. 1 divided by T is this. So 1 over T. And then I have got this one. And next I have to put the ln of K, ln of the inspiration rate. So it's equal to ln of, and then this respiration rate. And then I'll drag to this. And then I will plot this with this scatter plot. Because these are continuous variables, it's better to use this linear or continuous. So I put this one here. So I will add the axes. And then this is the ln R, and this is 1 over T carbon. And now to get the slope, we have to make the trend line to this, the best fit of trend line. So I will go to this, the trend line, and then you can use more option to get the best. So I will choose the linear line because we transform this into linear. So I will display the equation and the R. So here, look. So at 98% of the fitting, so the equation, the Y, is equal to this, with the linear. Now it's convert to the linear model. So from this, the very important parameter is this, the slope. The slope, if you see in the PowerPoint, we said slope is directly connected to the activation energy. Activation energy is calculated with the B times R. B is on the slope, this. So this means I will show you here. Now, active. To give the highlight, the pen. Now, okay. Activation energy E is equal to B times area. So this is now we get from the slope from the plots. We get the plot slope value. So minus E is equal to minus something value. So this minus by minus is deleted. So we can get R is R constant. The gas constant is known 8.314. So we can use that formula later also. So now I will use this plot here. And put here the coefficient variables B, okay, R, A, and EA. These are the very important parameters. So R is a gas constant, it is known 3.314 joule per mole or Kelvin. This is the unit. So B we get from this slope. This slope value is 30. 180.3, and A is the intercept value, this 130.134. So activation energy is calculated by B times R. B this times R. I'm sorry. Because this variable should be removed. Now, yeah. So we have we have E, we have ABR. So now we can calculate the rate of reaction constant. So this formula, K, the very important parameter, is equal to A is this. We have to fix this one times exponential function expo and minus E activation energy. This we have to fix again over R is a gas constant. This one we have to fix and times temperature. Or temperature is this variable, and then we can enter. So we drag to the temperature. Here are the values. K at the temperature of this is this value at the temperature of 10, and this is at 5 degrees centigrade, this is at 10, and this is at 15. So this is on the first 4 days, you know, the reaction rate at the first 4 days. What about in the second 8 days? We have to look this 8 in similar way. Okay, we can put here, and then we can change. I think these are the same. We can copy and we can paste. And here we convert this line this. Okay. So after that, we have to add to this. I will color this one maybe. Okay, the trend. I'll turn this solid line and of the color of red, let's say, I like. And then this have to fill. Oh, it's bad. Okay. This color is beautiful. Yeah. Now this is the first 4 day, and I will add the second one. Oh my God. Now we can click here again, David. Then we can select this data, and we can add the points, and the 8th day. X is the same, and the Y is here. Okay. Look how these are the points. So I will add the trend again for this trend line. Option more. Okay, select this linear regression. Yeah. I will display the chart. So we get this. For the second. This is 9.3. Yeah. The efficiency is a little bit decreased. Here the efficiency is very high. So how the metabolic process affect the model, you can understand from this as well. So you can modify this the trend line color. I see. Okay. Oh no. Salad, yeah. Yes. And the solid. Okay. So from this, okay, we can use now the slope is here, 34.92. Okay, these parameters are the same. It's 0.314. 34.92.2. 15.03, and activation energy is equal to B times this times this. How you can also how the energy increases with time, you can evaluate how this is 25, this is 29, is increase. And the reaction constant, we can also similarly compute. A is this one, we have to fix, and then times exponent minus activation energy, this, we have to fix over R, we have to fix times T, the temperature, this, and then enter. So now you can report this is the first 8. You can increase more. If you have more data, you can increase with more value. But the report should be this. You can make this beautiful plots. I can delete these grid lines. Not necessary, and I can make this bold. Line, I have to go to the line, I have to the solid line, and then the black, and the width is should be 1.575 is enough, and then the thick is for the moja outside, and that's the font, and then this one. And you can this also similar, and you can do this one. Okay. So this is for this, and this is one. Yeah. So the one you can put on your result is this plot plus this parameter, the K parameter and this coefficient parameter. This value are very important, and you can report in table. So you can use the empirical mathematical modeling with Excel as well. If you based on your background or based on your field of expertise, you can do the measured or the observed data with the theoretical data. You can fit which model can fit the base. So this means the 98% of the measured values explained by the mathematical model or this adherence equation. So that's very nice, I see. So this is the mathematical modeling to describe the temperature-based reaction constant. If you have question, I can. Otherwise, I will proceed for the next. Okay. Is clear?
Okay, thank you so much. What's the now? I think it'll be
okay. Yes, one hand. Okay, you can.
Yeah. Just I'll give the chance for Mr. Hasabu.
Yeah, I was wondering because he was just focusing on the. First of all, I would like to say thank for your presentation. But the second things I was wondering that you are just focusing on the continuous data or interval. But is it possible to, to try to give us an example on categorical data or nominal data? Is that possible?
Yes. I think the first was the categorical data. I'll show less. The first data, this. If I use this one, you can, I will label like A and B, C, D. Okay, I will take some of the sample from here. Okay. 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 Yeah. Let's say you have a measurement, one parameter it could be is under a category of A, and the other is under a category of B, and this C and D. So mostly, if you want to make the visualization, first you can make the mean and the standard deviation here. The average of this and the standard deviation of this, because the accuracy of the measurement, like the precision, you have to measure whether the process is okay or not under each category. So standard deviation of the sample, and then do this, and then I'll drag for all this. So, and I can also standard error, calculate standard error, standard deviation, this square root of this. Amen. Okay, sorry. Okay, this fix my diagram. I have to fix this over square root of 38. Yeah, this is the standard. Now I will use this for plot. Okay, this is A, this is E, this is C, and this is D. Okay, fix, and then okay. So I will go to the upload. So in this case, it's better to use, I recommend the bar chart. This insert, go to the bar chart, and you'll get like this. And then you can label this, add, click here, and you can edit this one, the label part. So the equal to and A, B, C, D. N, B, C, D, and enter. Okay. Mm-hmm. Yeah. Okay. Okay. That's okay. Minus. Okay. Character. Okay. I will modify this one less. Yes, this is the easiest way. Okay. You have here the category of A, the category of B, C, D. So we can similarly you can do the error bar as the one for standard error, just from the custom. If you wanna from your actual calculation, you can choose the custom and then specify. So I will use, let's say, error bar option, specify. So this, I will choose the standard error, that's more I'm interested in the page accuracy, so I will put like this, and you can customize this one, and you can make a border. Solid line and okay. This in one tick outside. So you can add the axis, let's say it's something the parameter that you wanna, and here the treatment or the block or the categorical variable that's you named, you can put, and you can figurative like this. Have you got it? I think this is for the categorical, and another the testing is similar, but then figurative you can put more. The bar is recommended, I think, for categorical variables. Else, the other is correlation. Correlation between variables. We can simply use the core function. Let's say this. We can put the array1 and array2. Let's say I would like to see the correlation between this variable and this variable. So first I will select this from this to the end, comma, and then I will add the array2. This and this and enter. So From this, I have got the R value is minus 0.2. They have, which means they have inverse relationship. The moderate significant relationship it shows me. However, I can, if I make the correlation between, let's say this, the weight loss, and firmness, let's say, here, let's say they have strong positive correlation. So at the weight loss of the food increase, the firmness of it, or the vegetable, maybe this product, I don't know. So if this weight loss is increased, the firmness is increased. If this is decreased, but the color is, they have inverse relationship. At the color change, it may decrease or increase the firmness. So this is one of the approach we can calculate, or we can use the same data and then data analysis. Here there is a correlation function. We can click this one, and then we can input the range. Let's say I will input this range. Okay, output. Okay, give me here. Give me this. Look, here the results are similar. This and this. So we can, if we have multiple parameter, we can use for multiple regression of correlation. The number of array we can increase. Okay, the other one, we can also see the simple regression the same way. Go to the data analysis. I think here is a regression part. So the Y range, let's say the Y is this. Yeah, less. And the X range, if I put the X range of this, what will be happen? We'll see. And then we'll put here the regression value. There it shows the R square is 62%. The firmness is explained by the time. This means Y, the firmness is equal to the coefficient is here 0.5, 0.52 times time plus intercept 3.10. Well, yes, 3.10. This is the relationship between time. So this can be explained, this firmness can be explained by this relationship at explained variance efficiency is 62% only. At R square, the correlation is 0.620%. So this is linear regression, simply. So we can use this data analysis. Or I think line sets. We can use also this line set. The same. the y in the m. And then the x and then you can calculate normal. It's okay. Force of P calculated. Okay, this let's say B. We'll see what will happen. So we get the same result. You can check this and this, the two. 3.3 the intercept, and this is the slope. So we can use one of the approach to calculate the relationship, the linear relationship between two variables, one dependent and one independent variable. This is simple linear regression technique. The other one I would like to show is the solver or the non-linear relationship. Let's say this is the time and this is the measured temperature. It can be compression temperature, it can be extraction temperature. This is the process variable. So we need to estimate by this nonlinear equation. So first we have to determine this temperature, the predicted temperature value. So initially we have to put for the initial parameter like A, B, and C. These are the variables that needs an optimization. So initial for A we give, let's say this 9 or 8 or 7. We can use this. We can 28. Let's say we can this 19. So we can as much as we like. You can put initial values, and then we can calculate this y is equal to A is this. We have to fix plus B is this one, and again we have fix times bracket 1 minus exponent minus t is this one, and over c is this. We have to fix, and then we have integer. I'm good. So it's okay. So we get it this one. After that we can drag the result. So we can make a plot. This I have to, let's say this in the predicted value. This time and insert this one, and then we get this one. So we can add a trend which type of fitting the model can fit better for this one. We can look or add a trend similar to the previous and go to the more option, and then we have to look to the best. Let's say if I click this one, it's not good. If I click this one, still it is not good. If it is I click this one, even it is not good. Again, okay. So if I click this one, maybe it should be, yeah, this is the better, the best. So the polynomial, more option, and then I will choose the polynomial. So I will display the equation here. Look, this is the predicted when we see 99, 1999, yeah, 991 with these parameters. Later we will see how this can be optimized. So after that, we have to make the sum square error. Sum square error is the measured one. This measured value minus this predicted value, the whole square is in words count. And the sum we have to sum this, the sum value, or this. Well, look, this is now an objective parameter. We have to minimize this sum square error value. We have to minimize this one. The average, we can solve the mean of this. First, I will show you how to minimize this one. So we can go to the data and then solver. We have to put here the solver. And here we have to set the objective, which are the objective. Our objective is this variable. We have to minimize this error. So by what? By minimizing these variables. We are going to, and changing objective is minimizing this error, and by changing what? The variables of this. And then here the solving is the non-linear option. So we have to, after that, we can solve. We click on solve button. Now, solver currently assertion they are satisfied. He did the solver with, he did 5 iteration. After 5 iteration, he gets an optimized variables. Now it's changed, yeah. Our initial value was different from now. Even the error, look, it reduces to 0.13. So 17. So we can click here. So this is now the exact variable. The very important variable, the optimized variable to get the minimum error. This. And then the mean square error, mean average. And the correlation. Correlation is the measured, yeah, well, the measured one and the predicted one, and the whole square. Yes. So at 999 point this, the coefficient this, now the formula will be y is equal to A is 9.30 plus B. B is 40.44 and 1 minus exponent of minus T divided by C. C is already 19.4. So with this, this is the optimized function to get the 99% of curve fitting model for this. So this is for non-linear by solver. You can minimize the error by optimizing the variables. This is another mathematical approach. The last but not the least we'll see is the design of experiment. Okay, on design of experiment, let's say I will show you this. We have 3 parameters or 3 major factors: the time, the temperature, and the energy. On let's say the product is popcorn yield. Popcorn yield. To get a best quality or to get the best yield of popcorn, it needs a consumption of time, which is heating time, and the consumption of energy to get the heat. So I have designed here with 2 levels and 1 center of each level with 3 factor, which is 2 to the power of 3 is 8. So with 2 center point or with replication is 10. We have the total of 10. So if we gonna design like I will put, let's say A is for the temperature, B is for the time, C is for the energy, and AB is for the interaction between time and temperature, A and C the interaction between energy, and BC is for that. And lastly, 1, 2, 3, 4, 5, ABC. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. This is the interaction. So I will the number of 1, let's say 1. Okay. I can put like this: 1, 2, 3, 4, 8. Okay, this is my design. And then for A, I'll put like -1, the minimum and the maximum. Minimum, maximum. This is the design. And for the B, minimum, maximum. This is the design. And for C, the minimum, maximum. Okay. The minimum and the maximum. Okay. And then this is the product AB, A times B. And then I'll drag. And this is A times C. And then this and this. And this is also B times C. Yeah. Okay. Okay. And this is also ABC. A times B and C. Okay. And I have the value 1. Okay, 1, 2. Okay. Sorry. This is the value. Okay. And 5. And 6 is here. 5, 7, 4, 8, 10. Okay. This is the yield, popcorn yield. Okay. Now I will put the center point, which is the midpoint is 0, 0. Point. Now this is the design, but we can resubstitute by this value. Like, let's say from this, I will find, okay, let's say -1 is you have to replace by the minimum for temperature time in the first year parameter. Okay, the minimum is 5, so I can put 5 and replace. And the maximum 1 is 50. You can replace. Okay, now it should be horizontal. Okay, 5. Yes. This is 5. This is 5. This is 5. And then this is 10. I mean 15. The maximum 15. Okay. The one. Okay, it did it. Okay, 0 is 10. Let's say. now it's the place. Okay, 150, 150, 150, and 150, and okay. Then the B is the temperature. Minimum is 20, maximum is 40, and the mid is 30. Okay, 20. I will put here 20. 40, 40. Yes, 20. Okay. Okay. 20. 20. 40. 40. And 30. And 30. The last one. Then the 30 is 30 and 60, 45. 13. 30. 30. 30. 60. Okay. And 45. Okay. So this is the design. We can now, this is our design. We can make randomize. Now we can put like randomize here. Rand is equal to rand. So we put and then so this is our randomize. No. No. Okay. Sorry. This is what. Okay. Okay, now we'll go to this the structure. Now we can go to the data analysis. From the data regression, okay. Now I have to select this part. I will show you like the PPT. First, we have to select this, the Y range. The Y range is this, the output, the yield that needs to optimize. And second, we choose this. And label there. And then we'll put this result here. Okay. Yes. Look. Now here we get the regression is R square adjusted is 31. Okay, this is 83, and with the adjust one is 31%. The results is not significant as size, but statistically here, all except the interaction effect between A and B. A and B, in a sense, the time and temperature are very significantly affect the yield of the popcorn. It's from this, but significantly important for this one in this case. But if we randomize, it's not randomized. But if we make this should be randomized, I will again repeat. Okay, to save time, I will use this one, the randomized one. I will use this one. If we randomize, I will go to this again. Here, I'll put the range is here, this one. This is the whole. Okay, the output. Give me the output around this. Okay. So from this, now look, the regression model is significant, 0.01. Here you can compare with non-randomization. It was, the result was here. You can see the difference with randomization. This is 0.015 and 0.02. This is above 0.05, which is not significant. Here there is a significant. So if it's a significance, we have to see the adjusted one. Even the adjusted R is 98. So that 98% of the yield crop can be explained by the temperature, the time, and the power with their interaction. They can explain. So from this, we can see the coefficient variable, which are very important to model. So here, the temperature. This shows the coefficient is positive 5.2. So the p-value tells us it's significant. So it has a positive effect on yield. If the temperature is at high temperature, the yield is increased, it says. The time also similarly, it has a positive effect. So with longer time, you can generate a good yield popcorn. However, with the energy, it has, even though it is less significant, it's not significant, but it reduces somewhat. The yield can reduce at high energy. You can see the minus side. And this is the highest, very important, and the much significance, but the coefficient also the higher, 13 points. So the synergy effect of time and temperature affects positively to the popcorn yield. And here the time and the energy, if we see, is very significant, but the higher temperature and the higher energy consumption can lead to decrease the yield of the popcorn. It decreases the yield. So we have to consider, we have to focus on optimizing the temperature and the energy consumption, because it's also the negative minus sign of the coefficient is minus sign. So we have to concern, we have to be conscious on these parameters need to optimize. They are significant, but in inverse way, in negative way. The other is time and temperature, energy, time and energy. At longer time, with higher energy consumption also leads to lose the yield of the popcorn. We lose. This also, the temperature and time is less significant. This is not significant than the three interaction. So to get positive synergy effects, these are the best parameter at temperature, at higher temperature and time. But we have to consider the energy consumption. At higher energy, it will damage the yield of the popcorn. So yield can be expressed now. Yield is equal to 5.25 temperature plus 6.75 time plus minus 4.5 minus 4.5 energy or power, plus the interaction effect 13.75 times temperature dot time plus the minus 12.5 temperature power plus negative 14.5 time energy or power minus 3.5 temperature time power plus the intercept 8.5. This is the optimize the function. We have to add 98.05% degree of coefficient. We can get this model. This is the linear model to get the best yield of popcorn. So this is what the design experiment, how it work in Excel with manually. This is the factorial based Excel. So with you can design your experiment like this, and then you can analyze the ANOVA and the regression, everything. You can statistically. So this is all about today. Thank you. If you have question, let me know.
Thank you so much, Zinabu, for this. I guess you did a great effort to explain all the basic statistics to advanced one. I think the most difficult one, if you need to learn the statistic in a better way, you have to use Excel. Otherwise, you will not learn the statistics, because if you're using software, you will not learn the behind, so like the theory behind the test, because by one click you can get the result, but how this result can be achieved, you have to use that one. Just you have to learn the statistics from the Excel, because you will learn all the basic statistics and all the equations, and you know like these values come from which equation that you are using. So thank you so much for this. Grateful. If you have any questions, comments, just raise your hand, and then I will give chance to everyone here. So anyone have a question? Down base Libby.
It's more of a bit mathematics, yeah.
Yeah, it's more mathematics. And I know that the Excel, because some of the people they don't know like how to use Excel, because Excel is complicated, because you need to know the equations. And then
yeah. Because in mathematical modeling, I think the theoretical background is also very important.
Yeah.
So behind your experimental data or behind your measured data, so if you think about modeling, that's also very important. Otherwise, the simple, the ANOVA, regression, correlation, and t-test and distributive statistics are very simple. We can manage without any theoretical background, or because the Excel, it has a different approach we can use as we did.
Yeah, I think this is the better way. Like, I guess if you need to evaluate the software, so like you're using software for data analysis, but if this result is good to compare with others, I think it's better to learn the theory and then using Excel just to be sure like this is the result, or there is some error, or if the error has come from what.
Muhammad Umar, I have
yeah. Muhammad Umar is here.
Yes, Zinabu. Yes. I was in and out for sometimes because I have meeting with my supervisor when you start your presentation, and really I understand very well. I understand. I didn't catch up from beginning, but I understand. Maybe you give very intensive details. I think, and also very good background regarding using Excel sheet analysis. And I don't know, maybe you mentioned already for everyone how to do the first sitting, the beginning of using the data analysis in Excel, because it is very important to know from beginning. But by the way, I'm sure you mentioned everything is important, and I'm happy, you did also how practically everyone can drive the data or can proceed with the analysis. I'm not so advanced in Excel statistical analysis as I know the basic one, or maybe I know until MANOVA one way, and even I use some these skills to help, like especially master student. For basic research, I think Excel analysis is important, everyone to know, and also it is very helpful, especially for undergraduate and also postgraduate, But for PhD, I think a very high level of statistical analysis method, it is also important. Yeah, by the way, it is really very nice, and I'm sure the people, they will share the final record, and they will enjoy also as well. Thank you so much, Zinabu, for the nice presentation. Thank you.
Okay, thank you, Emad.
So, does anyone have a questions? I think there are most of them here. Abdul Bagi. Does anyone have a questions, comment, something you need to share?
I have no more questions, but I will ask Zainabu, like, personally. So will you recommend, for instance, like very large number of data by using Excel comparing to other software? For instance, like, we used to analyze more than, I think, 500 results in one time by using IBM SPSS, as you are expert also IBM SPSS. And comparing to Excel, so how much, for instance, like, the error also as well, because we need the accurate result. Comparing those two type of analysis, or like more than IBM, more than RStudio, and also Minitab. Yeah, comparing those three type of analysis.
Yeah, for bulk data, I think these the Excel, the SPSS, and Minitab, they are very easy to interact with the tools, but the limitation is one, based on your computer processing capacity. The second one, if it is very too huge data with the huge parameter, I think it's better to use Python or R. That's very recommended one to do with one instruction, with one code you can't process with this programming language. But Excel also have a capacity, I think, in thousands it can run, especially if your computer is very good, because the processing is depend on the computer capacity. So you can also do with an Excel spread. 500 is very small, so you can run with Excel 500. But
Okay.
let's say in millions and 1,000, 10,000, something like this data, it's better to use with Python or with any programming language. That's recommended.
Okay. It is useful. That's mean the final conclusion, like, using Excel for short experiment maybe can be very useful comparing to other one.
Yeah,
it's fine. It's fine. Okay, thank you so much, Zinabu.
Yeah, Mohammed.
So if there is no questions, let us conclude this one, and then we finish the session for today.
Yeah, you can close.
Just okay. Thank you so much. As we conclude the statistical workshop number 2, hands-on statistical testing in Excel from basic to advanced. So we would like to express our sincere gratitude to each one of you for attending and actively engaged in today's session. Also, your participation and made this workshop a valuable learning experience for everyone. So a special thanks to our esteemed speaker, Mr. Zinabu, for sharing his expertise and providing us with a practical insight into statistical analysis. Also, we truly appreciate his time and effort to delivering such an information session. And we hope you find this workshop beneficial, and that is had equipped you would like with the useful skills to enhance your research and data analysis capabilities. Also, we encourage you like just to continue practical or just practicing and applying what you learn today. Also, thank you again for your being a part of this session. And we're looking forward to seeing you in the future workshop. So stay connected, keep learning, and don't hesitate to reach out if you have any questions. So thank you so much again and again. I will hope to see you like in the upcoming workshop. Maybe
Thank you.
after.
Thank you. Thank you, Osman. Yeah.
Thank you so much, really.
Thank you for the opportunity. It's nice time.
Yeah, thank you.